Well, up until now, we've been thinking our way through how to get more data into our Python programs. So far, we've looked at using external data files, we've looked at CSV files, and today we're going to look at getting data from the web using a module called requests. Of the many useful modules out there, the one we're going to work on today is called the requests module. Now, this is not one of the standard installations, and it doesn't even install with Anaconda. So when we get to the command line here towards the end, we'll install it, work through pip, and if pip doesn't work for you, we'll work on conda. But what we're going to do is use the request module as a way to get more data into our script. We've already looked at files, and we've looked at CSV files, but sometimes the data we want is actually on the web somewhere, and the requests module is a really easy way to get it. We're probably all familiar with how the web works and what the kind of architecture of that thing is. And so we have got here a little picture of a web server. All a web server is a computer, kind of sometimes big, kind of sometimes fast. It's connected to the internet. It's just up and running 24/7. And it waits for us to visit it or to ask for or to request a page or a data file that's on that server. And when it gets a request, it finds that file or finds that web page and it gives it to us or serves it to us. And we usually open that in a browser or something else like that. So when we search to the page, what happens is our browser sends a request to the server. We think about this as typing in a URL and then maybe hitting return or clicking on a link. But what happens in the interwebs is that a request, a bit of data, is sent to the server, and that starts a conversation that is has several cycles between us and the web server. The server's replies are called responses, and so there's this request-response cycle that we go through. And it looks like when we visit a page, sometimes it looks like we only ask for the thing and then we get it back. But actually, there's a lot going on here. The first one is, hey, are you there? And then the server says, yeah, I'm here. And then we say, can I have this page? And the server says, yeah, you can have that page. And then it says, okay, give me that page. And then the server gives us that page. And then if there are things like images on there, let's say there are 50 images on that page, we repeat that process for all 50 images. And so it sometimes takes a long time. That's why sometimes it takes a long time for these pages to download. But what's interesting is this request response model, and a browser knows how to do that automatically. But what the requests module allows us to do is to initiate that process from Python, which in effect turns our Python script into a web browser. So what we'll do is write a script, something like this on the left. I'll probably do mine in the interactive shell, but you could write this as a text file as well. And what we'll do is import the requests module, and we'll use the requests module to ask for a web page at a particular URL. And we'll get that back in the requests object, and then we can start to do things with it. So we'll take a closer look. We'll examine some of the parts, like the headers and the status code, stuff that is always under the hood that we typically never see. But when we do this in Python, we can see all of these bits and pieces. We'll look at maybe the encoding, and then the one that we're going to be really, really interested in is the text, and we'll pull that out. So what I want to do first is I want to go to this particular page, and I know this is a bit of an unwieldy URL. This is one that's up in our sandbox server for the DH program, and this is just a list of palindromes. I really like palindromes. I have a fondness for them. Palindromes, as you probably know, are strings that are spelled the same way forwards and backwards. So the word radar, for example, or race car. These are palindromes, but there's some really long ones too. So what we'll do is drop into the terminal window, and I'll go through that process of installing requests with pip, and then we'll go into the interactive shell, and we'll just start to play with the request module. Well, what I've done here is just open a browser window, and I've surfed to that URL to make sure that I have it correct and that I can actually see all of my palindromes. And you can see I've got quite a collection here. this is just a plain text file that I put up on the server, and there's one palindrome per line. And so that's the structure that we need to know. We will see what that looks like when it comes into Python. Just for safety's sake, later I'm just going to copy this URL right now so that I don't have to type it out again, because I will probably make a spelling mistake. All right, so back in the terminal window, what I need to do is to make sure that I do indeed actually have the requests module installed. So I'm just going to type pip install requests, and I'm going to confess I already have it installed. So you're going to see a lot of requirement already satisfied notices here. But if you don't have it, hopefully pip will install this and will install it in the proper place. And you can see here, requirement already satisfied. Now you'll notice that pip is in fact putting all of my modules into the Anaconda library. So if I drop into the Python interactive shell, the first thing I need to do is to import requests, and you'll see that I get no error message, and so that means that it did, yes, in fact, import requests properly. If that gives you an error message, it means that Python can't find the files in the requests module. So at that point, maybe go back and try to install it with conda. Go back to the command line and say conda install requests, and then try this again to see if that works any better. And if you're still having problems, let me know. I do want now, I'm going to create a URL variable and paste that URL because it's too much for me to type. I'm pretty lazy. And then I'm going to create now a requests object. Now I'm working interactively in the shell, and so I want not to have to type a lot of stuff. So I'm going to create a single letter variable called R, and that's going to be my requests object. If I were writing a script and I'm using Sublime or Atom or some other text editor to do this, I will create a better variable name than R. But I often do this when I work interactively in the shell. I just use single letter variable names. But again, if I'm writing a script, I want to use something that's more descriptive than a single letter. So I'm just going to be a little bit lazy here. So what I want is I want the requests module to go get that URL for me. And so inside the requests module is a Verbra function called get, and I just pass it a URL, and it will go out, send a request to that server, and then I will get back a whole bunch of information from the server. Here, no news is good news. That means that it worked and that I didn't have any errors. Now, if I do a directory on the requests object that I created, you can see that there's a whole bunch of these kind of magic methods up here. But there are some really interesting things down below. So, for example, I can look at the page's encoding, or I can look at its headers. I can look at this status code. We'll do that here in just a second. The one that I'm really interested in is the text of that page, but I can even ask my request object, what is the URL that I just accessed? I can't type that, but there's the URL we just went to. I can ask for the status code. The status code, HTTP status code, is 200. We all know the most famous one, which is 404, which means that that page wasn't there. But this is one that is very, very common, but we never see it, which is 200, which means everything is okay. Yes, the page is there. Yes, you can have it. There are no problems whatsoever. Status code 200. I can ask for the encoding of that page, and you can see it is 8859. There's one that says Latin 1, so this is not a Unicode page, if those things mean something to you. This particular server, no matter what the encoding of the document is, dishes it out as Latin 1, so live and learn, right? Now, the one I'm really interested in is the text of that particular page. So I'm going to get the text of the page, but I'm just going to slice that a little bit. And I want the first, I'm just going to take the first maybe, 200 characters on that. You can see what happens. The text of those palindromes is all here, but it's one giant long string. And even though my original document used one palindrome per line, those lines come in as encoded newline \n characters. So what I would like to do with this data is I would like to split this on the newline characters and turn it into a list. So I can do that pretty handily. Let's do palindromes, and I'm just going to use a comprehension to do that. So I'm going to say palindrome strip, and I want to strip it. Now I'm going to split this on the newline characters, but I haven't looked at the data carefully enough. There might be some extra stray spaces at the beginning of a palindrome, or some extra stray spaces at the end of a palindrome before the newline character. If that's the case, I would like to clean those up. I don't want any of those extra blank spaces at the beginning or the end, so I just want to make sure that I strip all of those off. If all of these strings are going to be clean anyway, then there's nothing there for Python to do. But if the strings are somewhat dirty, that is to say they have these extra spaces, I want to get rid of those. I'm going to do that for every palindrome or every pal in our text, but because that's a long string, I want to split that, and I'm going to split it on the newline characters. So this is a comprehension. I'm building a list, and I'm splitting a giant string on new lines, and for everything I get, I am stripping off any extra white space and then creating a giant list. So let's just slice lists a little bit. Let's get maybe, I don't know, 15 of those or something like that. And you can see what I get. Square brackets, obviously, for a list. Here's Dennis sinned. And you can see there's no extra white space in there, and there's no new line. There still is punctuation, and you'll notice, I mean, this is the hard, tricky part about it, right? There's punctuation in here. There are capital letters and lowercase letters, and so if we're going to check to make sure that all of these are palindromes, there's some extra processing we'll now start to need to do, right? Yeah. So that's how I can bring this data in, and I can start to work with it. So again, I've got a couple of different techniques now, right? I can use a file operator to get data from my hard drive. If I dump something out of a spreadsheet, that creates a CSV file, and I know how to work with a CSV file. But now I can also go out on the web, and using requests, I can very, very easily pull data into my Python script from the web as well, which is an easy way to do it. Before we go, let me show you one more thing here. I mentioned that there are headers as well, and these are what the headers look like. You can see that this is a dictionary, and it's a dictionary of key value pairs. Now, I may or may not be interested in what this is, but all of these headers are kind of metadata for that particular page. So let me just print that out. I'm going to use some single variable letters again for key and value in the headers, and I want to look through all the items in that header. And I'm going to print this out. I'm going to print the key, and then let's just do like, I don't know, triple colons here, a separator. This maybe makes those headers a little bit easier to see. So you can see the current date and time. You know exactly when I'm doing this. It's Sunday afternoon in Edmonton, but that is 6:49 p.m. in London, Greenwich Mean Time. The Sandbox server, the HukaDev server that we use, is running an Ubuntu operating system, and it's running a web server software Apache 2.4. This page was last modified on the 19th of August in 2018, so you can see it's been quite a while since I've added any new palindromes. The ETag one is a very interesting one. This is sort of like an encrypted hash code that the server builds based on that page. So in theory, if I changed even one character on that page, the ETag would change. Now that's a really interesting way for me to decide whether I have looked at the version of this page before or not. So sometimes web scrapers will actually take this ETag and stash it, and then if that ETag doesn't change, they know they've already looked at that page. Some other things, there's 4,264 characters in that. There's some server stuff here. The content type it's text, it's plain text. And so these are all just little tiny metadata things about that particular page. And again, this may or may not be important to you in your project. You may only want the content. You may only want the requests object.text. But maybe you're doing some other kinds of projects where you need a little metadata about pages, and that metadata is in the headers, and the request object gives you headers as well. Just a few last slides here before we're done for the day. I wanted to review this idea of chaining because it's one of the things that you'll see really regularly in Python. I love chaining. I love languages that chain like this. Not every language does, but Python does. And I just wanted to review the idea of reading a chain and understanding how that works. So let's just take a look at a chain that uses the requests module here so that we can see how Python is processing data as we move through. Now, the trick to chaining is to look at a part of the chain and to think in your head what kind of object that is right now. And then as we move through the chain, we substitute. What kind of object is it now? What kind of object is it now? What kind of object is it now? And so it's this mental process of swapping out objects that's crucial to this concept of reading chaining. So in this long one, let's just take a look here. So what we're doing at first is we're saying, okay, in the requests module, and we'll call it maybe a namespace. So in the requests module, there is a verb or a function called get. And I want the requests module to go out to that particular URL, which is a variable, and get the result. Now when that comes back, what this turns into is a request object. And we did a directory on that, right? A dir. And we can see that there's tons of stuff in there. There's magic methods in there. There's other kinds of little methods or functions that exist in there. There are bits of data in there that we can look at. So at this point, I know what I have is a request object. Now, that request object, I can get the encoding, I can get the headers, or I can get the text. Now, the request object has a text property, or it has a text attribute. So I know that that thing on the left will produce an object that has a text attribute. And now I know what that gives me back. Now, I happen to be looking at a string. So the first pair gave me a request object, but now what I'm looking at is a string. And because the data type has changed, now I know that I have every opportunity or every property, every method to work with a string value. So that object has methods like upper and lower and yes, split. So now, because it's text, I can split that on any character in the text, and I'm going to split here on new lines. Now when I split a text, I get a list. So at this point, the entire chain amounts to a list. Now that's not where I started. Requests.get gives me a requests object. But then I access the text on that object and I have a text. Texts can split, but when I split a text, I get a list. So in this chain, I move from object to string to list. And that's the crucial part about following chaining. And so if you don't do that mental substitution in your head, chains look like gobbledygook. There's no comprehension, there's no understanding about what we're actually trying to achieve. But the secret to reading chaining is to make these mental substitutions so that you know at any point along the chain what kind of data structure you happen to be looking at, right? And we'll see this a lot. Chaining makes Python really, really powerful. You can do a ton of stuff in a very tiny amount of space. Again, I love chaining. I love languages that chain, and I do chaining all the time, and so we'll see that. So you can see some of my favorite things about Python, comprehensions and chaining. There are two of them right there. Okay. So just to summarize now about where we've been in the last couple of slideshows, the problem that we've been facing is, how do I get more data into my Python program? There's more stuff out there than I can type, more than I want to type, certainly. So how do we get data in? Well, we've seen three techniques so far. The first one is just loading from an external data file. We use the with context manager as a way to do that. We can read and write, of course. But depending on what the format is of that stuff in the file, I probably need to use some Python techniques to clean it all up. Maybe it comes in as a string. Maybe I make a dictionary out of it. So I need to figure out how to clean it up. One size doesn't fit all here. I have to open that external data file, maybe in my text editor, to see what's in there so that I know how to clean it up. The second one we looked at were comma-separated values files, or CSV files. Classically, these come from spreadsheets. Every spreadsheet app on the planet can export into CSV. It's what they do. You do lose in that process. You lose the fonts, you lose the colorings, you lose line spacings, you lose that kind of formatting stuff that is in the spreadsheet. But that's okay, because Python doesn't know how to do anything with that anyway. So CSV is a plain text version. It's a plain text file with columns obviously separated by commas. It's just as easy to read a CSV file as it is an external data file, especially if we use Python's CSV reader object as a way to fetch the data. As we looked at in an earlier lecture, those rules for CSV are surprisingly complicated, and it helps that we have a CSV reader that knows all of the complexity of those rules so that I don't have to make it up, because I can't even remember all of that. And then today what we were looking at was pulling data in from the web. There's tons and tons and tons of stuff out there, weather reports and news items and blog pieces and Twitter and like everything. The internet and the web are the arena of big data, and all of that stuff is available to me, and I can start to pull that in. A simple way to get that into my Python script is to use the request module. Very, very easy to use. Again, it's not part of the standard distribution or the standard package of Python, but using pip or conda, it's very easy for me to install that, and it's very easy to use so that I can pull down pages. Now, if I'm doing something bigger, like let's say I need to pull down, data from 200 or 300 pages or 1,000 pages, I may or may not choose to stay with the requests module. I might choose to graduate to build a kind of a full-fledged web scraper object. And Python has a neat module to help us do that. It's called Scrapey. So if you're graduating beyond just a couple of pages, you might want to do some homework and study up on the Scrapey module so that you can use that to pull stuff down. All right, well, that's it for this particular lecture. Thank you very much. Good luck loading your data.